Hello everyone, this is Saumini Balasubramanian here, and along with me I have Lohitha, Sameera, Rajana and Tejeswara Sai Appikatla in as a team. And here we be presenting or basically giving a review on the fake news detection and hate speech detection using NLP. This topic is highly relevant today because the misinformation and the harmful language is rapidly spreading over online, and this is often influencing the public opinion. And in severe cases, it's causing a real world harm. The NLP offers powerful tools for us to help us address these issues, and through this presentation, we'll explore some of these methods. On to the next slide, we'll be seeing the agenda. So to guide you through our discussion, I'll be starting off with the introduction to what the fake news and the hate speech detection is all about and how NLP is involved in here. We'll then take a look onto the challenges in detecting these issues and explore on how the NLP provides a solution. Afterwards, we'll be covering some real-world applications of these NLP techniques, and then to conclude off with the challenges and the future directions in these fields. On to the next slide is the introduction. So what's the fake news detection is all about? The fake news detection is that which basically helps us focus on identifying the content created for us to mislead the people, while the hate speech detection aims to find and flag the harmful language that promotes the violence or hatred. Detecting these things is crucial and critical at the same time because the fake news can misspread the information on the important issues like the health or election, and the hate speech can incite the violence or harassment. By using NLP, we can address these issues through systematic analysis and create a safer, more reliable online space. Over the next slide, we'll be seeing the challenges in detecting the fake news and the hate speech. There are significant challenges in detecting the fake news and the hate speech. The fake news often closely mimics the real news and may use the emotional or sensational headlines to engage the readers, making it hard to distinguish. For the hate speech, the language is often context dependent and may use sarcasm, coded language, or cultural references too. For example, here we have the example as "great another pandemic" could be looking literal but then it's sarcastic. Likewise, many of the examples are there which might look neutral but then it holds offensive meanings in the actual context. So this can basically lead to a confusion within the detection models. On to the next slide, we'll be seeing how NLP helps us solve these problems. The NLP helps us solve these issues with the various techniques. Starting off with the text classification models that can basically distinguish between the real and the fake news and identity hate speech. The feature extraction methods like the TF-IDF highlight the important words, while the word embeddings capture the semantic relationships, helping the models understand the context. The models like Naive Bayes and SVM perform well with the label data, while the advanced models like the LSTM and GIU can capture word order and long-term dependencies, enhancing the detection accuracy. Over to the next slide, we'll be seeing the text classification. The text classification is essential in detecting the fake news and the hate speech. It works by assigning the labels to the text such as the real or fake for the news or identifying the hate speech. This classification process relies on the machine learning, which analyzes the patterns in text using the examples it's been trained on. First, the automated labeling makes the process efficient by eliminating the need for manual review, which would take too much time for the larger volumes of data. Next, we use the machine learning models like the Naive Bayes, support vector machines, advanced deep learning models. These models are trained on the label data, for instances, data marked as fake or real news, which allows them to recognize similar patterns in the new context. Finally, the text classification has real-time applications in platforms like social media, where it's often used to quickly filter or flag inappropriate or misleading content, ensuring a safe online environment. Further presentation will be carried over by Sameera Rajana.
Hi, this is Sameera Rajana and I'm here to talk about the TF and IDF. What is TF-IDF? The TF-IDF is a technique used to understand the importance of words in a document relative to a collection of documents. It helps us identify which words are most significant in a given text. So how does it work? The TF measures how often a word appears in a document. IDF measures how rare a word is across the entire corpus. The TF-IDF score is calculated by multiplying the TF and IDF. Why is it important? It is important in creating meaningful features for a machine learning models. It also identifies key points in a document. It ranks documents based on a relevance to a query. It also identifies main topics in a document collection. Moving on to the next slide, we have word embeddings. What are word embeddings? Word embeddings are a more powerful tool in NLP, enabling machines to understand and process human language more effectively. The numerical representations of words in a high-dimensional space. Words with similar meanings are placed closer together in this space. So why are they important? They are important in capturing the nuances of the language, and it also enhances model performance on text-based tasks. It also facilitates various NLP tasks like sentiment analysis, machine translation, and more. Coming to the applications of the word embeddings, they are applied in categorizing text into predefined classes. They are also helpful in determining sentiment expressed in the text. They are also helpful in translating text from one language to another. They are also helpful in ranking documents based on the relevance. And moving on to the next slide, we have naive Bayes and support vector machines. Naive Bayes and support vector machines are two popular classification algorithms in machine learning, often used in text classification and other tasks. Coming to naive Bayes. Based on Bayes' theorem, it assumes the features are independent of each other given the class label. They are simple and efficient, especially for large data sets. It also handles high-dimensional data very well. It works well with the text classification tasks. And coming to support vector machines. It aims to find the optimal hyperplane that separates data points into different classes. It is effective in high-dimensional spaces. It also handles complex decision boundaries. Its kernel trick allows for nonlinear classification. In the conclusion, the choice between the naive Bayes and SVM depends on the specific characteristics of the dataset and the desired outcome. For simple text-based classification tasks, naive Bayes is often a good choice. For more complex problems that require precise decision boundaries, SVM can be a powerful tool. However, it's essential to consider factors like dataset size, feature dimensionality, and the computational resources when making the decision. And moving on to the next slide, we have long short-term memory and gated recurrent unit. LSTMs and GRUs are powerful variants of recurrent neural networks designed to address the vanishing gradient problem that plagues traditional RNN. They are particularly well suited for tasks involving sequential data such as natural language processing, speech recognition, and time series analysis. LSTMs introduce a memory cell that can store information over long periods, enabling them to capture long-range dependencies. They have 3 gates. Forget gate. It determines which information to discard from the cell state. It also has input gate. It decides which information to store in cell state. It has output gate, which controls information from cell state to use to compute the output. Gated recurrent unit. GRUs are a simplified version of LSTMs, combining the forget and input gates into a single update gate. They have 2 gates. Reset gate. It determines how much of the past information to forget. Update gate. It controls how much new information to add to the hidden state. So moving on to the next slide, we have advanced NLP, transformers and BERT. Coming to BERT. BERT reads text bidirectionally, capturing context more accurately than single direction models. It excels at understanding meaning in complex structures like sarcasm or negations. Coming to transformers. Transformers, which power BERT, use self-attention to focus on important words, improving comprehension of context. This mechanism enables BERT to understand relationship between words regardless of position. So, why it matters? BERT handles ambiguous language and complex sentences effectively, making it ideal for nuanced tasks like sentiment analysis. In the real-world impact, BERT and transformers are valuable for detecting fake news and hate speech, boosting accuracy in handling challenging language tasks. The further presentation will be carried out by Teja.
Hello, this is Tejeswara Sai. Coming on to the next slide, we have the examples of NLP in action. Coming to the social media platforms like Twitter, Facebook, and Instagram rely on NLP to manage the massive influx of posts, detecting hate speech and misinformation efficiently. NLP models are trained on large datasets to identify keywords, language patterns, and tone, allowing them to flag inappropriate or false content. These tools help platforms respond swiftly, but given the complexities of language, human moderators often review flagged content to ensure accuracy and prevent errors. NLP also tracks misinformation trends, enabling platforms to act preemptively against harmful narratives. Coming to the fact checking, organizations like Snopes and PolitiFact leverage NLP to streamline the verification process, using it to scan claims, identify recurring falsehoods, and prioritize content for review. NLP uses models cross different statements with the verified information, helping fact checkers focus on high risk content. While NLP can efficiently highlight potential misinformation, human reviewers remain essential for nuanced issues like satire or complex political content, creating a balance between automation and accuracy. Coming to the content moderation, NLP enhances content moderation by automating the detection of harmful or inappropriate language in a large scale online interactions such as comment sections or forums. These tools analyze language patterns to identify content related to threats, harassment, or explicit material, reducing the burden on human moderators. However, due to the intricacies of language and cultural context, human moderators is still necessary to ensure flagged content aligns with the platform standards, allowing for a more accurate and safer online experience. Coming to the government initiatives, governments use NLP to monitor misinformation and harmful content during the sensitive events like elections or crises. NLP models scan social media and news for manipulative or divisive messaging, helping authorities to track harmful narratives and respond with accurate information to prevent destabilization. While valuable for public safety, these tools raise privacy concerns, so government use is often limited to high risk scenarios. Real time insights from NLP help agencies act proactively, addressing rumors quickly to maintain public order. Moving on to the next slide. In this project, we have used a few powerful tools and models to classify news articles as either real or fake. Python is our main programming language, with pandas handling the data processing and scikit-learn managing the train test split. We rely on the Hugging Face Transformers library for access to the pre-trained BERT model, which we fine-tuned specifically for binary classification. By fine-tuning BERT on this task, we enable the model to better distinguish between real and fake news articles, leveraging BERT's strength in understanding nuanced language patterns. We are working with a dataset from Kaggle that includes both fake and real news articles labeled as 0 and 1 respectively. Each article's text is tokenized using BERT's tokenizer, transforming the words into a format that BERT can process. After tokenizing, we feed the text into a fine-tuned BERT model, which then predicts the label accompanied by a confidence score that indicates how likely the article is to be either fake or real. This setup, combining pre-trained BERT NLP capabilities with a target fine-tuning, allows us to classify news articles accurately based on the distinct patterns present in their content. Moving on to the next slide, these are some of the live demo results that we have received or obtained after running the process. When we run a prediction with a fine-tuned BERT model, the output gives us two main pieces of information, a label and a confidence score. The label directly indicates whether the model classifies the news article as a fake or real. Specifically, label 0 corresponds to fake news and label 1 corresponds to real news. This binary setup allows us for a straightforward interpretation of the model's decision. The pre-trained model adapted to distinguish fake from real content quickly. These generates the labels based on the patterns it has learned during the training. The confidence score accompanying the label provides deeper insights into the model's certainty. Expressed as a percentage, this score reflects the model's belief in its prediction. For instance, if the score is 0.5228, it translates to a 52.28% confidence in classifying the article as a fake news. Higher confidence scores suggest that the model found strong recognizable patterns consisting with either fake or real news in this article. On the other hand, scores near 50% indicate less certainty, suggesting that the model detected elements that could be present in both types of articles, resulting in a closer call. This confidence metric is essential as it allows me to gauge reliability of each classification. Having both the label and the confidence score enables a more nuanced understanding of the each prediction. When the model is highly confident in its classification, we can generally trust its judgment. However, with the borderline scores, we might look into an article further or consider additional adjustments to the model. The confidence score adds an extra layer of transparency, showing us when the model is making a closer call versus when it's more tentative. This helps inform how we interpret the results and allows us to better assess the model's performance over time, potentially guiding further fine tuning if needed. Moving on to the next slide, these are some of the challenges and future directions that we have for this fake news detection project. One limitation we face is the possibility of false positives and false negatives, where the model might mistakenly classify harmless content as harmful or fail to detect genuinely harmful material. This misclassification can undermine the model's effectiveness and require constant monitoring. Another issue is bias within the model. Since NLP models learn from the existing data, they can inadvertently pick up and reflect societal biases present in the training dataset, which can lead to unfair or skewed decisions. Additionally, the tactics behind the fake news and the hate speech continue to evolve, which means my model must be regularly updated to stay effective against new form of manipulation and misinformation. To address these limitations, we are looking at the several future directions for improvement. One is enhancing the model's explainability to gain a clearer understanding of why the model made this particular decision. This could help identify biases or errors in reasoning, making the model's output more trustworthy and interpretable. Another approach involves combining NLP with a social network analysis, allowing us to track and analyze the spread of fake news more comprehensively. By studying how misinformation circulates within the networks, we can better understand and mitigate its reach. Additionally, we are exploring the potential of developing multimodal systems that can analyze text, images, and videos simultaneously. This would provide a more holistic approach, enabling us to tackle the misinformation that spans multiple content formats. Moving on to the next slide, in this we have tackled the challenges of detecting the fake news and hate speech and looked at how NLP can address these complex issues. We reviewed the real world applications where NLP are actively used to manage harmful content online, learning about both the strengths and the limitations they face. From handling evolving tactics in misinformation to understanding the ethical concerns about the bias, it's clear that it is a challenging area that requires continuous development and careful consideration. Some key takeaways for me are that the fake news and the hate speech are constantly evolving, which demand sophisticated and adaptable detection techniques. NLP offers powerful tools to combat these issues, but there are still significant limitations like potential misclassifications and inherited biases that need to be actively managed. Moving forward, advancements in NLP and AI will continue to improve the accuracy and reliability of content detection, making online spaces safer for everyone. Thank you for following along with this project of ours.